Exponents with variable bases. So, if you look at this expression, you can see how we're simplifying inside the brackets. First, multiplying powers with the same base, you add. Negative 7 plus 5 is negative 2, divided by, remember this is a 2 to the 1 here, so you now have quotient negative 2 minus 1 is negative 3, and power to a power gives you 2 to the negative 12. Would anything happen differently if the base was a variable instead of a number? And the answer is no, as long as these bases are the same. So the base of the powers in the first example is 2, and the base of the powers in the second example is, well, okay, let's be a little more specific then. Let's say that this base is a number, which in our case is 2, and in the second example is a variable, x. All of the same rules for exponents apply for simplifying. However, when we simplify powers with variable bases, we will arrive at an expression that involves variables rather than a number. 2 to the negative 12 is just a number, right? I mean, it's 1 over 2 to the 12th, which is 1 over, I think, 4096. Gets out calculator. 2 to the negative 12. Math, enter. Yes, 1 over 4096, right? This evaluates. This doesn't. This is an expression. Simplify that following. Oh my God. It should be simplify the following. Oh well, it's already gone off to the printer. And write the answers using positive exponents only. Okay, well, we can do this. So it's x to the 2 plus negative 7, which is x to the negative 5 over x to the negative 6. Negative 5 minus negative 6 is 1. So x to the 1, which is just x. We could also have said it's x to the 2 plus negative 7, right? Plus because we're multiplying, then we're dividing, so we go minus negative 6, which is going to give us a 1. 2 plus negative 7 is negative 5 plus 6, which is 1. Here. So we have 2 minus 1. So negative 3 and 9. Maybe we'll leave that first. We've got x to the 2 minus 1, y to the 3 minus 5, and z to the 5. No z down here. So this is negative 1/3 x, y to the negative 2, z to the 5th. Now, positive exponents only. So we're going to go with negative 1x z to the 5th over, the 3 is on the bottom, as is the y, so over 3y squared. Order of operations, we need to square this first. So before we can do the multiply, mn cubed. Okay, this will become positive 9. This is m cubed squared, which is m to the 6th, and this is n to the negative 4th squared, which is n to the negative 8. We're doing power to a power, right? So that we are squaring. We're squaring the negative. You think of it as 3 squared. We're squaring the negative. So in this case, it's really negative 3 times negative 3. That'll give us a positive. This will give us negative 18 for a number, m to the 7th. So 6 plus 1. N to the 3 plus negative 8. So negative 18m to the 7th, n to the 5th. Oh my god, I've got to fire the guy doing the key for me. I need to pause and make some changes here. Oops, I'm not so hot either. So 3 plus negative 8 is negative 5. Positive exponents only. So up top we've got negative 18 m to the 7th over n to the 5th. Now you could extend this. You put the negative sign in front to say this whole expression is negative. You could extend this and say that the top is negative. It doesn't really matter. Simplify and then evaluate. Okay, so it's a lot easier if we simplify this first and then we plug in the numbers and work it out. So let's give this a try. We got a 6, we got a to the 3 minus 1, we got b to the negative 1. Okay, and remember there's 1's here. So it's negative 1 minus 1, and we've got c to the 5 minus 3. 6a squared, b to the negative 2, c squared. So 6a squared c squared over b squared. Okay, and now we can substitute in. So 6, okay, we've got a formula, sort of, right? Substitution. We've got a 4 over, and we've got a 3. So I'm going to kick this up here. 6 times 4 times 16 over 9. Could do a little bit of canceling. 3 goes into that twice, into that 3 times. That gives me 8 times 10 is 80, plus 8 times 6, which is 40, is 128 over 3. Okay, so we end up with 128 over 3. B. We've got to do this first. So we have 12a squared c to the 1/2 over a cubed b cubed. So 12a to the 2 minus 3. I'm just going to leave the b down there. C to the 1/2 b cubed. That's 12a to the negative 1, c to the 1/2 over b cubed. There are easier ways to do this. You could just cross this off and take that out and just say the a squared goes into the a, leaving you with 1a on the bottom. So it's 12 c to the 1/2 over a b cubed. Now we substitute. So c is 4. Thankfully that has a square root, right, because we need that, over negative 2 and 3 cubed. So it's 12 times 2 over negative 2 times 27. 2's cancel. 3 goes into that 4 times. 3 goes into that 9 times. So we get 4 on the top and negative 9. So it's negative 4 ninths. Okay, that's your final answer, is negative 4 over 9. Simplify the following and write the answers using positive exponents only. Okay, so we have to do this first, power to a power, right? This is x to the 2 times 3, y to the 1 times 3, which we'll just write as y cubed, z cubed, times x, y squared, over x, z squared. Well, that's going to be a 6. I'm going to cross this off. and this off. So we're taking out the x top and bottom. I'm going to take the z squared out and leave me with a z to the 1. So I get x to the 6th. I've got y 3 and 2 is y to the 5th. And a z. So x, y to the 5th, z. Oh, wow. Okay, so we have a quotient to a power, so it's going to be a 1/2 times 2, which is a to the 1, b to the 8, over 3/2 times 2 is 3, so that's a cubed, b to the 10th. So that's a 1 there. So the a to the 1 is going to take out one of these, leaving an a squared, b to the 8th. Okay, and always write a 1 in when you get rid of something. That's going to take that out, leaving a b squared. So on the top, 1, on the bottom, a squared, b squared. Okay, you can also, of course, do this. So it would be a to the 1 minus 3, b to the 8 minus 10, which is a to the negative 2, b to the negative 2, which is 1 over a squared, b squared. Looks like there's room to move down. Okay. So power to a power. This is 36 to the 1. It becomes 36 to the negative 3. Actually, you know what? Hang on. We put the brakes on. Before we do anything, let's simplify. 12 goes into 36 3 times. That's a 1 there. This x to the 1 takes the x squared down to an x. The y up top takes this down to a y cubed. And the z takes the z to the 4th to a z cubed. So on the top, we have a 3x z cubed, on the bottom y cubed to the negative 3. It's a fraction, so it becomes y cubed over 3x z cubed to the positive 3, which is, and I'm running off my tablet, y to the 9th, 3 cubed, 27, x cubed, z to the 9th. Okay, so 3 to the 1 and then cubed. Okay. Right, and I think you'll find that a lot easier than if you actually work with this. If we can simplify first. So m to the 4th, m to the 12th, will be an m to the 8th. The n to the negative 2, so we have negative m times 9n squared, right? That is going to move up top. Okay, this is gone. And 16m to the 8th to the 1/2. Okay, the square root of this, right, is 3n over 4m to the 4th. Okay, power to a power. 9 to the 1/2, which is 3, square root 9. 2 times a half is 1. 16 to the 1/2, square root 16, which is 4. M to the 8 times 1/2, multiplied by negative m. So the whole expression is negative. We get a 3n, we get a 4, and an m cubed, right? Because this m takes one of these away, leaving us with an m cubed on the bottom. Next up, exercises. Okay, you've got the sheet. If you don't, I'll scroll. I'll leave it there for a second. You can always pause and write stuff down. you don't have these sheets, you can write stuff down. And there's the rest. Again, pause, write stuff down. Here are the answers. So let's leave those up for a second so you can look at them. Whoops, they're all on one page. Here's some more answers. Again, pause, pause, pause. And here are the remaining answers. Okay, so lots of work, right? All you've got to do, it's just a matter of getting on top of it and getting to it. And there are exercises for homework, and there is work in the book for homework, and really you just have to get lots of practice.